Welcome to solverfy.
We're asked to draw all of the structural and geometrical isomers of bromochloropropene. So in each of these isomers, there are a couple of components that have to be present in order for it to be a valid isomer. First, the bromo in the name lets us know that we're going to have a Br group in each of our isomers. Chloro means we're going to have a Cl group. And propene means two things. We're going to have a 3-carbon chain. And because it's propene, we're drawing an alkene. We are going to have a carbon-carbon double bond in each of our isomers. So first, let's start with our structural isomers. The first one I'm going to draw is I'm going to have my base carbon group, and I'm going to go ahead and put my double bond off of the first one. I'm going to have a carbon there, and I'm going to go ahead and put my bromine and chlorine off of the last carbon. And if you want even more guidance, I guess, to make sure that all of your isomers are valid, just based on this first isomer alone, we can tell that the chemical formula of what we're drawing is C3H4BrCl. So just another way to check yourself is to go through each of your isomers and make sure that you have 3 carbons, 4 hydrogens, 1 bromine, and 1 chlorine. My second structural isomer, I'm going to keep the location of the double bond constant. Because it is a propene, I really don't need to move that location of the double bond to the second, because that would essentially be repetitive. That would just be the same compound flipped upside down. And I'm going to move the chlorine here and the bromine here. And then for my third isomer, I'm basically going to switch the locations of the bromine and the chlorine. And those are my 3 structural isomers. For my geometrical isomer, I'm going to start each of these with my carbon-carbon double bond, and that's going to give me 4 hydrogens, 1 more carbon, a bromine, and a chlorine to arrange around each of the bonds. So however you want to start, I'm going to start with my bromine here, a hydrogen here, a methyl group, and a chlorine. The isomer to that would be to switch the relative positions of the bromine and the chlorine. Oh, 3 comes after 2. I can also put my chlorine here and a hydrogen here. And then I can rotate the chlorine and the hydrogen about that double bond. I can put my bromine and my hydrogen on that side together. And then rotate them. And then those are all of my possible isomers with a methyl group, but I can actually combine my bromine or my chlorine with my carbon. So instead of CH3, I can make it CH2Cl or CH2Br. So I'll draw those isomers real quick. Start with a bromine and a hydrogen. That leaves 2 hydrogens left with a chlorine. As I did with the others, I can rotate the bromine and hydrogen. And then for my last 2 geometrical isomers, I can, instead of having a chlorine here, I can have CH2Br. And then for my last geometrical isomer, I can just rotate the hydrogen and the chlorine. And so those are my 10 geometrical isomers for bromochloropropene and my 3 structural isomers for 13 total isomers.